Hey peeps, sorry I couldn't be with you today, but in the interest of not falling behind, I went ahead and did a screencast of today's lecture so we can learn all about the oligopoly. Go ahead and get out your notes, and just as a heads up, there's a couple extra slides that I've put in here to help clarify some points and information. You don't need to write those in, just when a slide comes up that you don't have in your notes, just pay close attention to that section. Pay attention to all of it. So today we're learning about the oligopoly. What we're going to learn, why oligopolists have an incentive to act in ways that reduce their combined profit, and why oligopolies can benefit from the act of collusion, working together with the other members of their industry. So understanding the oligopoly. First of all, an oligopoly is an industry that only has a few sellers. In addition to having a small number of sellers, an oligopoly is characterized by something called interdependence, which is a relationship in which the profit of each firm depends on the actions of the other firms in the market. This isn't true for monopolies because, by definition, there's no other firms for them to consider. It's also not true of competitive markets because there's so many firms in a competitive market that no one firm has a significant effect on the outcome of the others. However, in an oligopoly, an industry with just a few sellers, the outcome for each seller depends on the behavior of the others. Interdependence makes studying a market a lot more interesting because that means firms have to observe and then predict the behavior of the other firm. They're kind of playing a guessing game. But it also makes it more complicated. To understand the strategies that oligopolies use, we have to do more than just find the point where marginal cost and marginal revenue curves intersect. So how do they find out how much they're going to produce? How do they know what their profit maximizing output is? Up until this point, we've always answered the quantity that maximizes profit. When a firm is in perfect competition or a firm is a monopoly, then we assume that the firm is going to use its cost curves to determine what its profit maximizing output is. Oligopolies do things a little bit differently. In order to understand how an oligopoly works, we're going to look at a very simplified version of an oligopoly. We'll look at a market that only has two competitors. That's called a duopoly, and the two businesses are known as duopolists. So, let's imagine that there's only two producers of a chemical called lysine, which is an animal feed additive. To make things even simpler, let's also suppose that once a company has incurred the fixed cost that it needs to produce lysine, the marginal cost of producing another pound is zero. So the two companies in our example are concerned only with the revenue that they receive from sales. That's all they care about. So this chart shows a hypothetical demand schedule for lysine and the total revenue of the industry at each price quantity combination. So if this were a perfectly competitive industry, each firm would have an incentive to produce more as long as the market price was above marginal cost. Since marginal cost is assumed to be zero, that would mean that at equilibrium, lysine would be provided for free. Firms would produce until price equaled zero, yielding a total output of 120 million pounds and zero revenue for both firms. However, with two firms in the industry, it would seem foolish to allow price and revenue to plummet to zero. Each would realize that with more production comes a lower market price. So each firm would, like a monopolist, see that the profits would be higher if it and its rivals limited their production. So how much are they going to produce? How do they determine that? One possibility is that the two companies will engage in something called collusion. Collusion is where the companies will cooperate to raise their joint profits. The strongest form of collusion is called a cartel, and that's a group of producers with an agreement to work together to limit output and increase price, and therefore increase profit. The world's most famous cartel is the Organization of Petroleum Exporting Countries, or OPEC. I'm sure you've heard of them. OPEC is actually a cartel made up of governments rather than just firms. So, cartels are obviously illegal, but let's ignore law for the moment. Suppose the firms producing lysine were to form a cartel, and this cartel decided to act as though it was a monopoly. It's going to maximize total industry profits. Now, it's obvious from this table that in order to maximize the combined profits of the firm, this cartel should set total industry output at 60 million pounds of lysine. That would sell at a price of $6 a pound, and that would lead to $360 million in revenue, the maximum amount of revenue possible. Then the only question would be how much of that 60 million pounds each firm gets to produce. A fair solution might be for each firm to produce 30 million pounds and receive each $180 million in revenue. But even if the two firms agreed on such a deal, they might have a problem. Each of the firms would have an incentive to break their word and produce more than the agreed upon quantity. So consider what would happen if one firm honored its agreement, producing only 30 million pounds, but the other firm ignored its promise and produced 40 million pounds. This increase in total output would drive the price down from $6 to $5 per pound. So they'd be snidely whiplash there. The price at which 70 million pounds are demanded is the $6. The industry's total revenue would fall from 360 million to 350 million. However, the cheating firm's revenue, the one that produced more than it was supposed to, would rise from 180 million to 200 million. Since we're assuming a marginal cost of zero, this would mean a $20 million increase in profits. But both firms' presidents might make exactly the same calculation. And if both firms would produce 40 million pounds of lysine, the price would drop to $4 a pound. So each firm's profit would fall from $180 million to $160 million. The incentive to cheat motivates the firms to produce more than the quantity that maximizes their joint profits, rather than limiting output as a true monopolist would, since they're only competing with themselves, basically. We know that a profit-maximizing monopolist sets marginal cost, which in this case is zero, equal to marginal revenue, MC equals MR. But this isn't how oligopolies operate. So it would seem to be profitable for any one firm in an oligopoly to increase production, even if that increase reduces profits of the industry total. But if everybody thinks that way, the result is that everyone is going to earn a lower profit. Until now, we've been able to analyze producer behavior by asking what a producer should do to maximize their profits. But even if the duopolists are both trying to maximize profits, what does this predict about their behavior? Will they engage in collusion? Will they reach and hold an agreement that maximizes their combined profits? Or will they engage in what's called non-cooperative behavior, with each firm acting in its own self-interest, even though this will eventually have the effect of driving down everybody's profits? Both strategies can be carried out with a goal of profit maximization, which will actually, but which of those is actually going to describe their behavior? How are they going to choose to act? Now you can see why oligopoly is a puzzle. There's only a small number of players, making collusion a real possibility. If there were dozens or hundreds of firms, it would be safe to assume that they would behave non-cooperatively. Yet when there's only a handful of firms in an industry, it's hard to determine whether collusion will actually occur. So collusion and competition. Oligopoly firms can increase their profit by colluding to restrict output or raise prices. Maintaining collusive agreements is difficult because there's an incentive to cheat. Collusion, as we know, is illegal. But some firms do use collusion in order to raise their profits. They just do it what's called tacit collusion, where they don't have any written agreements about it. All right, price versus quantity competition. So sometimes, as we've seen, oligopolistic firms just ignore the rules. But more often they develop strategies for making the best of the situation depending on what they know or assume they know about the other firm's behavior. The uncertainties of oligopoly behavior make it harder to model than the behavior of monopolist or perfectly competitive firms, but models do exist. So one such model is an example of price competition, and it was developed by a French economist named Joseph Bertrand. According to the Bertrand model, oligopolists repeatedly undercut each other's prices, charging a bit less than the others to steal their customers, until price reaches the level of marginal cost, as it would under perfect competition. Another French economist, Augustin Cournot, focused instead on quantity competition, which had oligopolists choosing quantities and charging as much as possible for those quantities, rather than choosing prices and selling as much as possible at those prices. According to the Cournot model, each oligopolist treats the output of its competitors as fixed and restricts output to that quantity that will maximize profit given the fixed output of others. The firm's restriction of output in the Cournot model results in lower overall output levels and therefore higher prices than would happen under perfect competition. And each firm is going to earn a positive economic profit in that case. So let's look at an example. All right. Consider American Airlines and British Airways, which we will assume are duopolists with exclusive rights to fly the Chicago-London route. When the economy is strong and a lot of people want to fly between Chicago and London, American Airlines and British Airways might assume the number of passengers the other can carry is constrained. For example, not enough landing slots or terminal gates available at the airport. In this environment, they're likely to behave in the Cournot model and price above marginal cost. Say charging $800 per round trip. But when business climate is poor, the two airlines are likely to find that they have a lot of empty seats, and a fare of $800 and no capacity constraints is going to cause a lot of problems. What are these airlines going to do? Recent history tells us they will engage in a price war by slashing their ticket prices. If American Airlines were to try to maintain a price of $800, it would soon find itself undercut by British Airways, which would charge $750 and steal its customers. In turn, American Airlines would undercut British Airways by charging $700, and so on. As long as each firm finds that it can capture the customers by cutting price, each will continue cutting and cutting until price is equal to marginal cost. Going any lower than that would incur an unavoidable loss. That is the outcome that Bertrand predicted. So Bertrand predicted that price would eventually equal marginal cost due to this cost cutting. Oligopolists would understandably prefer to avoid the Bertrand behavior because it earns them zero profits. Lacking an environment that imposes constraints on their output capacity, firms try other means of avoiding direct price competition so they can avoid getting into these price-cutting wars. One way that they can avoid direct price competition is producing products that are not perfect substitutes, but are instead different from one another. That's called product differentiation. Producing differentiated products allows oligopolists to cultivate a loyal set of customers and to charge prices that are higher than marginal costs. Think of expensive eyeglasses or expensive sunglasses that pretty much look the same as the cheap pairs, but they have a brand name on them. People are going to be willing to spend more on a brand name even though they look very similar to the cheaper pair. Okay, so let's talk about game theory. In our duopoly example and in real life, each oligopolistic firm realizes both that its profit depends on what its competitor does and that its competitor's profit depends on what it does. That is, the two firms are in a situation of interdependence, whereby each firm's decisions significantly affect the profit of the other firm. In effect, the two firms are playing a game in which the profit of each player depends not only on its own actions, but on those of the other player. In order to understand more fully how oligopolists behave, economists and mathematicians have developed the idea of game theory. So let's see how game theory helps us to understand it in oligopoly. Game theory deals with any situation in which the reward to any one player, which is called a payoff, depends not only on his or her own actions, but also on those of the other players of the game. In the case of oligopolistic firms, the payoff is simply the firm's profit. When there's only two players, as in that lysine duopoly that we looked at, the interdependence between the players can be represented with a payoff matrix, like this one here. Each row corresponds to an action by one player. Each column corresponds to an action by the other. For simplicity, let's assume that each firm can pick only one of two alternatives. Either produce 300 million pounds of lysine or produce 30 million pounds of lysine or produce 40 million pounds of lysine. The matrix contains 4 boxes. Each is divided by a diagonal line. Each box shows the payoff to the 2 firms that results from a pair of choices. The number below the diagonal shows firm 1's profits. The number above the diagonal shows firm 2's profits. These payoffs show what we concluded from our earlier analysis. The combined profit of the 2 firms is maximized if they each produce 30 million pounds. Either firm can, however, increase its own profits by producing 40 million pounds if the other produces only 30 million pounds. But if both produce 40 million pounds, both will have lower profits than if they both held the output down to 30 million. This particular situation is a version of the famous prisoner's dilemma that you might have heard of. Let's see what that looks like. First of all, we'll talk about the different types of outcomes in the game theory. The first is the payoff matrix, which we just looked at. The dominant strategy is an action when it is the player's best action regardless of the action taken by the other player. So if you play the dominant strategy, it means you play whichever cards are best for you. The Nash equilibrium is also called the non-cooperative equilibrium, is the result when each player in a game chooses the action that maximizes his or her own profit given the actions of the other players. Okay, let's look at the prisoner's dilemma. So the story goes that there's 2 accomplices in crime, Crook 1 and Crook 2. The police have enough evidence to put both of them behind bars for at least 5 years. They also know that the pair have committed a more serious crime, one that carries a 20-year sentence. Unfortunately, they don't have enough evidence to convict the 2 crooks on that charge. To do so, they would need each of those prisoners to implicate the other in that second larger crime. So the police put the 2 in separate cells and say the following to each. Here's the deal. If neither of you confesses, then you'll both be sent to prison for 2 years. If you confess and implicate your partner, and your partner doesn't do the same, we'll reduce your sentence to 1 year. But if your partner confesses and you don't, you'll get the maximum 20 years. If you both confess, you both get 5 years. So let's look at the payoffs of the prisoners face by looking at the matrix. Depending on the decision of each to remain, the columns and rows show the decisions they have to make. They can either remain silent or confess. So let's assume that the prisoners have no way to communicate and they have not sworn an oath not to harm each other or anything of that sort. Each is acting solely in their own self-interest. What are they going to do? The answer is clear. Both should confess. Look at the first from Crook 1 point of view. He is better off confessing regardless of what Crook 2 does. If Crook 2 doesn't confess, Crook 1's confession reduces his own sentence from 5 years to 1 year. If Crook 2 does confess, then Crook 1's confession will reduce his sentence to 5 years. Either way, it's clear that it's in Crook 1's best interest to confess. And because Crook 2 faces the same incentives, it's clearly in Crook 2's interest to confess as well. So to confess in this situation is the dominant strategy. It is the best play for both characters. Regardless, it's the best play for Crook 1 regardless of what Crook 2 does, and vice versa. So when both crooks confess, they reach an equilibrium of the game. We've used equilibrium many times throughout economics, but in this case it's an outcome in which no individual or firm has any incentive to change their action. In game theory, this kind of equilibrium is called the Nash equilibrium. That's actually named after John Nash, interestingly enough, who the movie A Beautiful Mind was based off of. Nobel Prize winning mathematician. The Nash equilibrium does not take into account the effect, because players in a Nash equilibrium do not take into account the effect of their actions on others, it's called a non-cooperative equilibrium. They're not working together in any way. So if we go back for a second to look at this previous matrix, each firm is better off producing the higher output, regardless of what the other firm does. Yet, if both produce 40 million pounds of lysine, both are going to be worse off than if they had followed their agreement and produced only the 30 million pounds. In both cases, then, the pursuit of individual self-interest in the effort to maximize profits, or in the previous example, to minimize jail time, has the reverse effect of hurting both players. Okay. Overcoming the prisoner's dilemma. We'll talk about repeated interaction and tacit collusion in just a second. I'm going to take a short break. Okay, I'm back. So, picking up where we left off. Repeated interactions and tacit collusion. Repeated interaction can lead to strategic behavior, tit-for-tat strategy, and tacit collusion. What do those things mean? Let's start with repeated interaction. First of all, the two players in our prisoner's dilemma were playing what is known as a one-shot game. They play the game with each other only once. They get to choose once and for all whether to confess or to remain silent, and that's it. However, most games that oligopolists play are not one-shot games. Instead, the players expect to play the game repeatedly with the same rivals over and over again. An oligopolist usually expects to be in business for many years and knows that a decision today about whether to cheat is likely to affect the decision of other firms in the future. So, a smart oligopolist doesn't just decide what to do based on the effect on profit in the short run. Instead, the smart oligopolist engages in strategic behavior, taking into account the effects of their actions on the future actions of the other players in the game. And under some conditions, oligopolists that behave strategically can manage to behave as if they had a formal agreement to collude, if they're really good at strategy. Suppose that our two firms expect to be in the lysine business for many years and therefore expect to play the game of cheat versus collude many times. Would they really betray each other time and time again? Let's look at a graph that represents their repeated interactions. So would they betray each other over and over again? Probably not. Suppose that each firm considers two strategies. In one strategy, it always cheats, producing 40 million pounds of lysine each year, regardless of what the other firm does. And in the other strategy, it starts with good behavior, producing only 30 million pounds in the first year, and then watches to see what its rival does. If the other firm also keeps its production down to 30 million pounds, each firm will stay cooperative, producing 30 million pounds again for the next year. But if one firm breaks its promise and produces 40 million pounds the next year, the other firm will take the gloves off and also produce 40 million pounds the next year. This strategy, start by behaving cooperatively, but therefore thereafter do whatever the other player did in the previous period, is called tit for tat. The tit for tat strategy offers a reward to the other player for cooperative behavior. If you behave cooperatively, so will I. It also provides a punishment for cheating. If you cheat, don't expect the other player to be nice in the future. The payoff to each firm of each of these strategies would depend on which strategy the other firm chooses. So let's look at the 4 different possibilities that could happen here. If one firm plays tit for tat, and so does the other firm, both firms will make a profit of 180 million that year. So if both tit for tat, they'll both make 180 million. If one firm plays always cheat, but the other plays tit for tat, then one will make a profit of 200 million the first year, but only 160 million per year thereafter. If one firm plays tit for tat, but the other plays always cheat, one makes a profit of only 150 million in the first year, but 160 million per year thereafter. 4, if one firm plays always cheat and the other does the same, both firms will make a profit of $160 million each year. So which strategy is better? Always cheat or tit for tat? Whichever one is more profitable depends on 2 things. How many years each firm expects to play the game, and what strategy its rival plans on following. If the firm expects the lysine business to end in the near future, it is in effect playing a one-shot game, so it might as well cheat and grab everything that it can. But if the firm expects to be in the business for a long time and thinks the other firm is likely to play tit for tat, it will make more profits over the long run by playing tit for tat as well. The lesson of this story is that when oligopolists expect to compete with each other over an extended period of time, each individual firm will often conclude that it is in its own best interest to be helpful to the other firms in the industry. So it'll restrict its output in a way that raises the profits for other firms, expecting them to return the favor. When this type of unspoken agreement comes about, we call that tacit collusion. All right, last section, oligopoly in practice. How do oligopolies usually work in practice? The answer depends on the legal framework that limits what firms can do, on the underlying ability of firms in a given industry to cooperate without actually making formal agreements, which, remember, are illegal. So, we're going to talk about the legal constraints, antitrust policy, what factors limit tacit collusion, the causes and effects of price wars, product differentiation, price leadership, non-price competition, and how important oligopolies are in the real world. So, start with briefly antitrust legislation. You guys have heard of the Sherman Act. These are laws that make cartels, collusion, and certain anti-competitive business practices illegal. They are so very strict in the United States that businesses can't even discuss prices together in most cases. Factors that limit tacit collusion. Although tacit collusion is common, it rarely allows an industry to push prices all the way up to what would be considered a monopoly level. Collusion is usually really far from perfect as well. A variety of factors make it hard for an industry to coordinate on high prices. The first one is large numbers. So suppose that there were 3 instead of 2 firms in the lysine industry, and that each was only producing 20 million pounds. In that case, any one firm that decided to produce an extra 10 million pounds would gain more in short-term profits and lose less once another firm responded in kind and also produced 10 million pounds. That's because there's fewer units on which to feel the price effect. The general point of that is if more firms are in an oligopoly, the less of an incentive any one firm has to be cooperative with the others. One of the second limiting factors, complex products and pricing schemes. So in our simplified example of lysine, there was the 2 firms that produced only one product. But in reality, oligopolists sell thousands, tens of thousands of different products. I mean, a Walmart Supercenter has over 100,000 items in it. And under these circumstances, as when there's a large number of firms, keeping track of what the other firms are producing and what prices they're charging is going to be really difficult. This makes it hard to determine whether or not a firm is cheating on that tacit agreement that they have. Differences in interests. In the lysine example, a tacit agreement for the firms to split the market equally is a natural outcome, probably acceptable to both firms. You know, you make 30 million, I make 30 million. In other situations, however, firms often differ both in their perceptions about what is fair and what's in their real interest. For example, suppose that one firm in a duopoly was a long-established producer and that another more recent entrant into the industry was the other business. The long-established firm might feel that it deserved to continue producing more than the newer firm, but the newer firm might feel that it was entitled to 50% of the business. Alternatively, suppose the newer firm has newer, better manufacturing equipment. Their marginal costs were lower than the long-established firms. Even if they could agree on market shares, they would then disagree about what the profit-maximizing level of output would be because it's cheaper for the newer firm to produce. The last one, the bargaining power of buyers. Often oligopolists sell not to individual consumers, but they sell to large buyers. Think of the buying power that Walmart has. Other industrial enterprises, nationwide chains of stores, and so on. These large buyers are in a position to bargain for lower prices from the oligopolists. They can ask for a discount and then warn that they're going to go to a competitor if they don't get the discount that they want. That's exactly what Walmart does. An important reason that large retailers like Target and Walmart are able to offer lower prices to customers lower prices than small retailers are, is because they have this ability to use their vast size to extract lower prices from the oligopolistic suppliers. Product differentiation and tacit collusion. In many oligopolies, firms produce products that consumers regard as similar but not identical. Think Coke and Pepsi. A $10 difference in the price is not going to make too many customers switch from a Ford to a Chrysler, vice versa. Sometimes differences between products are real, like Fruit Loops and Wheaties, very different types of cereals. Sometimes they exist mainly in the minds of consumers, like Coke and Pepsi. Either way, the effect is to reduce the intensity of competition among firms. Consumers are not going to rush to buy whichever product is the cheapest because they think the products are different. As you might imagine, oligopolists welcome that power that comes where consumers think their product is different, better than that of a competitor. So in many oligopolistic industries, firms make considerable efforts to create the perception that their product is different. They engage in something called product differentiation. A firm that tries to differentiate its product may do so by altering what it actually produces, making it actually different, adding extras, choosing different designs for the box or for the product itself. It may also use advertising and marketing campaigns to create differentiation in the minds of the consumers, like having different sports celebrity endorsers. Even though its product is more or less identical to that of the products of its rivals, it's going to try and make it look different to the consumer. Whatever the nature of product differentiation, oligopolists producing differentiated products often reach a tacit understanding not to compete on price. So they'll have very similar prices, but instead of competing on price, they'll just have brand loyalty. For example, during the years when the great majority of cars sold in the United States were produced by those big three automakers, General Motors, Ford, and Chrysler, there was this unwritten rule that none of the three companies would try to gain market share by making its cars noticeably cheaper than those of the other two. But then who decided on the overall price of cars? Well, the biggest and the oldest company, General Motors. It would announce its prices for the year first, and then the other companies would adopt similar prices. That whole pattern of behavior, where one company tacitly sets prices for the industry as a whole, that's called price leadership. Interestingly, firms that have a tacit agreement not to compete on price often engage in vigorous non-price competition, adding new features to their products, spending large sums on ads that proclaim the inferiority of their rivals' offerings, and so on. This is why with car dealerships you get add-ons like sunroofs and satellite radio, and they're trying to make, I just bought a Ford car and it had the sync thing where you could Bluetooth your phone to it. That was their product differentiation, their non-price competition. So how important are oligopolies? Well, we've seen that across industries, the oligopoly is far more common than either perfect competition or monopoly. When we try to analyze the oligopoly, the economist's usual way of thinking, asking how self-interested individuals would behave, then analyzing their interaction, doesn't work as well as we might hope because we do not know whether rival firms are going to engage in non-cooperative behavior or tacit collusion. Given the prevalence of oligopolies, then, there's so many of them, so many industries are oligopolistic. In many cases, the limits to collusion keep prices relatively close to marginal costs. In other words, the industry behaves almost as if it was perfectly competitive. So we have a really hard time modeling actual oligopoly firm behavior. But there are a lot of them in the real world, so they are considered important. Most economists look pragmatically at oligopolies. It's difficult and messy to understand them compared to something like perfect competition or even monopolies. But always keep in mind that oligopolies are important. There's a lot of them out there in our market. There's a lot of them out there in the world. So I think that is it on the oligopoly. Any questions that you have about this, I will answer next class period. I have a couple worksheets for you guys to do that you'll get from the sub, where you'll be able to practice game theory. And next class period, we will start on monopolistic competition. I'll see you guys on Thursday.